This is a Year 10 Set 2 out of 5 maths class at Ashton-on-Mersey High School in Trafford. The school is part of the Multi-Academy Dean Trust. The targets for the group range from A star to C, and their Key Stage 2 levels range from 4B to 5C, with the majority 4A and 5C. The lesson is about standard form. The teacher is Joe Brown, and the observer is Jeremy Richardson.
Good morning, everyone. Thank you. Sit yourselves down. Can I ask you to get out your exercise books and your planners, please, your pencil cases and your calculators today. Okay, let's get ourselves organised. We have been doing some work in the last couple of weeks on special numbers. We've looked at primes, we've looked at factors, we've looked at multiples and various things to do with those. And then we've gone on and we've looked at powers. Okay. To start with this morning, we're going to have a little bit of a fun starter with some revision of some work that we've been doing on powers. Okay, so you're going to need your whiteboards at the moment. So if you could find your whiteboards, make sure they're clear. Okay. And I'm going to give you some things to think about. Okay, they're going to be on the board. Okay. So, got some choices. What would you rather eat? I'm going to unveil these. We're going to have a think about it, have a look at what's underneath the containers and make a choice. And then I'm going to ask you why you've made that choice. Okay? Remember, we're in a maths lesson. Okay, folks, ready? Okay, when you've had a chat, when you've got some ideas what you're going to choose, I'd like you to write a response on your board. Keep your board down, please. 3, 2, 1, show me. Oh, fantastic. Fantastic. Right, okay. Hold your boards up. Okay, fantastic. Right, I can see some great boards. Brilliant. So, what have you chosen?
4 to the power 3 cockroaches.
4 to the power 3 cockroaches. Why?
Because then you'd get 64, but 7 squared is only 49, so you get more.
Okay, so you want to eat, you've told me that there's 64 cockroaches and there are 49 mealworms, so you're going to eat the cockroaches, you're going to eat more of them. Fantastic. Okay, good choice. Okay, you're hungry in the jungle? Okay, fab. Okay, anybody else like to talk about their answer? Molly?
If you had to eat something, you wouldn't want to eat more. So I went with 7 squared mealworms because, one, they're shorter and they're not very big, and 49 of them, I'd rather eat that than big cockroaches.
Okay. Right, the vegetarian one, Reese. Okay. Have a think. Vomit fruit. Apparently, they're not allowed to eat these on the subway in, I think it's Thailand. Somebody was telling me yesterday when I was putting this together, because they smell, they make the whole place stink. When you go into supermarkets, you can smell them. They're vomit fruit. And then 100-year fermented eggs. Tough questions, these. These are grade AA star maths. So some of you in here might really struggle. You might have to ask your neighbour. You might have to turn around and ask the people behind you. Okay, so have a chat, have a think. You were right, Molly. Have a think. This is a tough one. Real challenge. Excellent. 2 girls, straight into their books, having a good look through. We've done it. Don't have to rely on your memory, guys.
What did you do
You've
here?
not finished. You're halfway through the sum. Don't go.
125 to the power 1 over 3 times that again, because there were 2.
Question mark, please.
So that's similar there, isn't it?
Okay, 10 seconds.
Two. 3 times 2.
Olivia, okay, I'm going to ask you for your reasoning. I can't see what's on your board, so I don't know whether it's right or wrong, but you're a smart cookie and I know you can explain what you've done.
I put 9 minus 2 for the 100-year-old fermented egg because I did 9 minus 2, which equals 0.009.
Okay, can I just write that down because I can't hold too many numbers in my head. So you've said, oops, clicked on that. You've said 9 minus 2 is 0.009.
9. And then I did 8 to the power 2.5, 2 and 3/4, 2 and a third.
2/3.
Yeah.
Yeah.
So I did 8 and did the cube root of 8, which is 2.
So the cube root of 8 is 2. Yeah.
And then I squared that, which is 4.
Okay. Fab. So you chose that one. Can anybody comment on what Olivia's done? Anybody comment on what Olivia's done? Is she right to start with? Because I don't know. I couldn't see a board. I've randomly picked her and said, can she explain? And she's done a marvellous job of explaining.
For the top one, for 9 to the power minus 2, I did 1 over 9 squared, because it's a minus.
Brilliant. So the minus is 1 over 9 squared. Fab.
And then I did 1 over 81, because it's 9 squared.
Okay. Right. Who's right? Are either of them right? Are they both the same? Anybody want to draw anything from that? Dan?
I would say Abby's one would be right because when it's 9 to the power of negative 2,
Okay.
with the negative you put 1 over.
Okay. So we're happy with that. Is that the same as that?
Yeah.
Yeah? Do we agree? Do we disagree? How do we find out? Oh, go for it, Abby.
Divide the top number from the bottom number.
So divide the top number by the bottom number. You've all got calcs, so let's do it. Let's see if it's right. Okay. Chanel, I've not spoken to you today. Hiya, how are you doing? Have you done 1 divided by 81 for me?
Yeah.
Have you got an answer?
Yeah.
Fabulous. What have you got?
0.01234567.
Right. So, was this answer correct? No. Okay. Fab. Fantastic. Just to come back to what the actual answer was, the minus means 1 over. Can you remember the mathematical word that I taught you that meant sort of 1 over, what the minus meant? It's a mathematical word. Great. So many hands up. Johnny.
It's the reciprocal.
The reciprocal, fantastic. Right, folks. Today's lesson is going to be about standard form. Now, we've done a brief piece of work on standard form. You know a little bit about it, okay? 30 seconds of thought while you're writing down the title and the learning objective. 30 seconds to think about what is standard form. If you're an alien walking into this room for the first time, what would you tell them about standard form? What do you know? Matt. Okay, just Matt, can you tell me anything you know about standard form?
If the power has a negative number in it, the decimal place moves to the left.
Okay, so if the power has a negative in it, the decimal place moves to the left. What kind of number would that be? What kind of number would that be? You can tell me. Conrad.
A negative number.
Would it be negative? Yep, so we've got standard form numbers and negatives. So if I wrote this on the board, in fact, Mike, give me a standard form number with a minus in the power.
8.2 times 10 to the minus 3.
Would that give you a negative number if you wrote that as an ordinary number?
No.
We're going like this. No. Who can explain? Who can elaborate? Who can help Conrad out? Megan, I'm going to pick on you, and I know you don't want to be picked on. So, are you able to tell me anything about what this number should look like? Will it be negative, and what?
If
might
it's
it look like?
-3, a negative number, then it'll be 0 point something.
So it'd be 0 point something. So what type of number would it be?
A decimal.
A decimal. Anybody want to add anything else on there? Charlotte?
Because it's a -3, you'll be moving the numbers to the right.
Okay. What do we use standard form for? What do we use standard form for? Brilliant. Josh?
To simplify, either really big or really small numbers.
Really big or really small numbers, okay? What does standard form numbers look like again? Just remind me, where's all this come from? Just
The first number has to be between 1 and 10, and then it times 10 to the power, however many places you move the decimal point.
fantastic, okay? Anybody know what this is? I don't know what this is. It's not a rocket launcher for sending naughty children across the corridor. That's what it looks like, isn't it? Anybody any ideas? Any ideas? Reese, I've not spoken to you today. Any ideas?
Is it a telescope?
It is a telescope, okay? Telescope for looking out at the stars and at the planets, okay? And you're not going to quite use this today, but you're going to imagine that you are an astronomer, okay? In front of you, you have an envelope. Can you find your little brown envelope? Can you empty your cards out in front of you and spread them out in front of you so you can see all of them? There should be one between two. Have you got one there? Have you not got one there? No worries. Here's some I prepared earlier, in good Blue Peter fashion. There you go. Okay. Right. Okay, spread them all out so that you can see them. It's nice. Goodbye. Yeah. Oh, thank you. Okay, right guys, on the board there are my objectives for today's lesson. You're working with standard form today. I see it as 3 different tasks that you could possibly do today. What I'd like you to do is work with your partner and see what information you can extract from this, keeping in mind those 3 objectives on the board. Which card will meet each objective? So, talk to your partner, you've got about 20 minutes to see what you can get from this. Off you go.
Where would you go to find out how to do the second
Distance from the sun. So if you're going to get a pilot.
Where would you look it? Would you need to look it up, or would you ask?
Yeah, okay, right, I'll leave you to it. I'll come back and see how you get on in a minute. Okay?
Okay. And how long do you get to do that in? Is that at the when do you do this response?
It's after like every term, and she puts one in the book, and then you answer it like straight away, and then if she marks your book and she like asks you when you arrive you're not done it or you're not sure what to do.
Right. Okay. And do you enjoy that?
Yeah.
Yeah. What do you like about it?
I was like and how you've got to work it out and how everything works out in the end and how it equals something.
So you like to get an answer in
Like
the
a
end?
challenge and stuff, yeah.
You like the challenge in it. Do you find the lesson too challenging, or do you find it's about right for you?
Yeah, it's about right, because if you do find it challenging, and then it makes it really easy to work out in the end.
And what does she do that makes it easy to work out?
She explains it in an easier way, or like if you're really stuck, then she'll come along and just just explain it easily.
Okay, thank you very much, Miguel. Thank you. How are you doing that?
Well, we've just done Pluto, and it says it's the lightest planet, and it has 1 followed by 22 zeros. So we've written it out.
Right.
And then to put in standard form, it's a number between 1 and 10, so it's 1 times 10 to the power, and then however many places the decimal point's moved, which is 22, so it's to the power 22.
So you've written the mass of Pluto in standard form. Great. And is that what you're going to do? What's your strategy for solving this problem?
We're going to see if we can find the mass of all the planets and then put them in standard form.
Put them in standard form, and then what's the next step?
Calculate the distance from the sun.
And have you done much work on standard form before?
We've done a bit, and we've done a bit last year as well, so it's kind of like refresh and then do some harder ones.
Are you enjoying this?
Yeah.
Do you often get these sort of challenges like this?
Yeah, sometimes we get like a puzzle thing, and we have to work them out to fit them together.
Okay. Well, good luck with it.
Okay.
What have you actually got to do?
So, if you want me just to come over and just have a little look at what you're doing.
Have you worked out what you've got to do?
If you're completely befuddled,
Yeah, we're
red,
supposed to
can I come around?
just see which one's the largest and then see which one's the smallest and then put them in order.
You can do this, guys.
I see. And how are you doing that? Looks a bit complicated to me.
Yeah, we're just using our calculators at the moment. We'll use a standard form button, which is this one here.
Oh, so you're using a standard form button on the calculator?
Yeah, so it would be like this one. It would be 7.22. Then times 10, then just 8. And it gives you that answer.
Oh, I see. Tell me what you're doing.
7.22 times 10.
Okay, so you're working out the distance from the sun.
Yeah. Can you read what that says?
Jupiter is 7.22 times 10 to the power 8 kilometres further from the Sun than Mercury. So then you'll add Mercury on top of that.
Okay.
5.7 times 10.
A lot of zeros there. Do you know what your target grade is in there?
Sorry. It's a B.
A B?
Yeah.
A B. And do you know what you've got to do in order to get a B, a grade B?
Yeah, I need to work on my Pythagoras compound measures and vectors.
And how do you know that?
Because it was from a previous test that we did, but it's not in this book.
Oh, I see. So some previous tests. Are these the yellow ones that
Yeah.
Right, so there's the things that you need to do some work on. Did Miss come and give you an extra card?
Yeah.
Yes.
What was the extra card? This one?
Yeah.
Why
Fantastic.
why
So
did
you're
you
working
get
out
this
the
extra
distance from the
card?
planet to the sun, that's great.
She just gave it us.
I think Miss
So-
thinks we can.
What does it
Do
tell
it.
you
Yeah,
somewhere?
like-
There's a card.
Do you think
that
she
tells
could do it?
Yeah.
Where is it?
Okay.
Yeah.
Is that because you're really good at
You should
this?
you should calculate the
Yeah.
distance from the sun.
Yeah?
And there's one
So what are
that
your
says
target
put your answer in
grades
standard
then?
form, and there it is.
An A?
So
What's your target
sharing
grade?
the distance
A C?
Yeah.
But between you, you can do this, you reckon?
Yeah, yeah.
Okay?
How would you do this?
Okay?
Talk me through it.
Yep, coming round.
Like, it's 40,000 kilometres for every hour. So then,
Yeah.
like, you would see. So that's,
You'd have to do speed equals distance divided by time and that. Well, first we have to work out all the distances for these,
Yeah.
and then do the speed and time and everything.
Right, that's where you're going wrong, because you put times 10 to the power 20 times 10 to the power 7. No, that's not an number in standard form. You're trying to use the standard form button. Yes, you've got to put that in standard form first. You remember.
Let's be 27.
yeah.
Okay, so does that make sense to you now?
Yeah.
Right, guys.
So you move that twice.
I'm going to give you an extra card to think about.
To the right, then you move this one.
The average speed of a space rocket, 40,000 kilometres per hour. What questions could you pose yourself with this?
Yeah, to travel to like Mars and things like that.
You could look at travelling to Mars and things like that. What could you ask?
How long it takes.
How long it takes. So what is that you're calculating?
Speed, time and distance.
Speed, time and distance. So how long is it? Which one of those is it? Speed, time or distance to around. Okay. I've just said what are you calculating? You said speed, distance, time, and you said how long is it? Well, which one is that? Is that a time, a distance, or a speed? A time. Okay. I've talked to lots of groups of people, and I just want a quick snapshot of where we're up to. Johnny, would you tell me what you're working out with Matt there?
We're working out the distances from the Sun for each of the planets.
Fantastic. So you're working out the distances. Thinking about my objectives on the board, which ones have you met there, would you say? What have you used? Top, middle or bottom?
Middle.
Middle, okay. Can you give me a card that you think meets that objective that you've used?
Mercury.
Read Mercury for me.
Mercury is 58 million kilometres from the Sun.
Okay, 58 million kilometres from the Sun. Does that involve that. Can anybody can I ask you just to stop? I know you just want to just do your own thing, just for 30 seconds, folks, because I'm going to ask you to grade your work on this in a minute. Johnny said that the Mercury card makes him think he's met this objective. Would you agree with that? So the Mercury card says something like 58 million kilometres. Does that meet that objective? Laura?
No, because he's not added, subtracted or multiplied it.
Brilliant. He's not added, subtracted or multiplied or divided anything. He's just written the number in standard form. Fab. Okay. Right, guys. I want you just to very quickly grab your planners. Think about this first objective. Green, if you think you can put a number in standard form. Johnny's given us an example of a card. Yellow if you think, yeah, I'm pretty much there. Red if you think, don't know what I'm doing. If you haven't got coloured cards, thumbs please. Okay? Brilliant. Almost everybody on green, a few yellows. Fantastic. Right, guys. Pop your planners down and carry on with your task. All you've done is put the planets in the distance they are from the sun in standard form.
No, the mass.
The mass, okay. Are they in any order or are they just random?
I think we tried to put them from smallest to bigger.
Okay, so you think those are from the lightest to the heaviest, okay?
So with Mars, what did you have to do in order to get it in the same
We had
units?
to use that standard form and times it by 1,000 to use that. And then it ended up being 3.3 times 10 to the power 23.
So how did you do the multiplication of timesing that by 1,000? Did you do it on your calculator or could you do it mentally?
Just did it on the calculator.
Did you do it on your calculator? Right, okay. So this is them all in order of mass?
Mm-hmm. No, in order, no. Just
Right, so you've got all the masses into the same.
yeah.
And what's your next task?
To do distances.
Distances, right. Is there anything particular that's come up about distances?
Not yet.
Just moving on to
Getting in order, yeah.
Get them in order.
Yeah.
Right. And for this, which of those success criteria has it enabled you to reach doing this?
Probably grade B.
Grade B?
Yeah.
Okay, so what is the
So don't think yet you've solved simple and complex problems.
No, I think I'd be more of a distance.
You think the distance one will give you that opportunity to get the B star? And what are your target grades? What's your target grade?
A star.
A star, okay. And what's your target grade?
I think it's an A.
You think it's an A? Okay.
Yeah, so.
Do you know what you've got to do in order to achieve the A star? It's quite challenging, isn't it?
It's to like revise more on coordinates and
think about that first?
like negative numbers and that sort of doing now should help me.
That should help you because you're doing some work with negative numbers.
Yeah,
That's great. Thanks very much. You've finished the other card, so you've got this one. How are you going to solve that problem?
We thought we'd put 40,000 kilometres per hour an hour in standard form first, and then come up with a question and use multiplication, subtraction and division to figure out.
Okay, so in this one, how will that help you solve that one?
Well, we thought we could do the distance from Earth to Neptune.
Okay.
And it would be the distance from Neptune to the Sun minus the distance from Earth from the Sun. Is that what I said? And then divided by 4 times 10 to the power 4.
If you manage to do that calculation, which of those success criteria will you have reached?
2 more minutes just to finish the task
You reached
you
B
are
star.
doing.
Thank you.
I just want a quick summary of what you've done, because I didn't really set you a task. I said, here's some cards, have a look at them. And some of you were like, what am I doing with these cards? Somebody like to start me off and tell me what they did first of all, what math they've learnt or what they were doing. Morgan, your hand went straight up there, dead keen.
Well, first we used the distances that had been given to us and then used them to work out the other ones, because some of them said Jupiter is so far away, further than Mercury.
Okay, so you were given the distances first. Tell me what the distances were doing. What were they about? What were the distances about?
Distances from the sun.
Brilliant. What did you do once you'd got the distances, people? What some of you, I said, well, what have you done with that? So what did you do with that once you'd worked out the distances? Josh here.
We ordered how far they are from the sun, from like the closest to the most far away.
Fantastic, absolutely brilliant. So Josh and Conrad posed their own question. They went, right, I've got these distances, what can I do with them? I can put them in order of how far they are from the sun. Fantastic. Right, can I just flick some answers on the board? Because I know we get kind of obsessed with answers. We can just, you know, everybody's like, am I right? Am I right? Well, how do I know? So let's have a look. Are you right? Okay. You can see Abby going, yeah, I'm right, it's good. Okay, so let's get rid of the answers, because, you know, it's not necessarily always about the answers, it's about the learning that's taken place. So we'll get that out of the way. Okay. Have a look at them, have a think about them. Lots of you did put them in order. Right, some people got an extra card. Josh and Nathan, you were two of the people that got an early yellow card. You were given the speed of the space rocket. What did you do with it?
We remembered the little triangle with the distance divided by like the speed and time and everything. So we just picked a planet and we picked Venus.
Yeah.
And we got the triangle,
Yeah.
but instead of putting D for distance, we just used our calculations instead, and then we got our answer.
Okay. Did you use, for Venus, did you use 1.1 times 10 to the 8?
No.
Why not?
Because on here it says Venus is 4 times 10 to the power of 7 kilometres closer to the sun than Earth, so we just used that. Because that already tells us how far it is from Earth.
In front of you, or around you, is a big sheet of paper. Okay? Can you find that big sheet of paper, one between two? The final task is to do this, and it's quite a challenging task in the short amount of time that I'm going to give you. Okay? You are going to write your own GCSE style question using these criteria. Now, Johnny showed us a card before that met that criteria. The boys, Josh and Nathan, talked to you about how they found the time it would take to get from Earth to Venus. That's quite complex. In your twos, I'd like you to pick a criteria, put a grade at the top, which grade you think your question is going to meet. I want you to write a question, and I want you to blue tack it with your bit of blue tack to the wall.
What's the question then?
The question is, the distance from Jimmy's house to Bob's house is 5 times 10 to the power of 6.
5 times 10 to the power of 6 what?
Kilometres. Yeah, kilometres. It takes him 5.5 hours to get there. How fast is he walking?
No, that's fine.
Cycling.
Have you worked out roughly what the answer is?
No, we just created a number and just
It might
went
help
from
to
there.
work out roughly what the answer is and
Yeah.
see if you could cycle at that speed.
Yeah.
If you have lightning bike, then like on the pedals, it's got fireworks to make it go faster.
Come on, guys. I need to have it written down now. All right. Whoa. That wall, please. Just that we can't use it today. Yeah, just over anything. Just stick it over. You got your blue tack? Excellent. First one going up. Brilliant.
Right, let's figure out the answer.
Come on, Dan, get yours up as well. Right, guys, you should be answering a question now. Did you get that?
I see.
Any question on a whiteboard?
Squared, yeah.
Okay, which question are you answering?
Alright, okay.
The blue, so
So
which one's
it's
that?
1.8 times 10 to the power cube squared. So it's that, and then squared at the end.
Brilliant. Okay, go for it then.
How are you
Your
getting on with
faces,
it?
please.
We've kind of just like worked out the first bit.
Okay, and what's that first bit?
We've worked out Mercury from the sun in standard form.
Right,
and now we
okay.
just have to work out how far Pluto is.
Good luck.
Put your hand up if you chose a grade C question. Put your hand up if you chose a grade C question.
This to work out.
Yeah, you chose grade C question. Okay? Fab. Cop out, Michael, you know that's a cop out.
I did two.
You did two? Okay, put your hand up if you did a grade B question. Fantastic. Who did a B star question? Right, what about the rest of you? What have you done? Right. Conrad, tell me your answer to that.
Is it 8.4 times 10 to the power of 10?
I asked you for an answer, not is it?
It is, sorry, 8.4 times 10 to the power of 10.
8.4 times 10 to the power of 10. Do you agree with that?
No.
What did you get?
8.4 times 10 to the power 11.
What did you get?
8.4 times 10 to the power 11.
What did you do wrong?
Must have miscounted a 0.
Must have miscounted the zeros, but you know what you're doing. Right, guys. Okay. Last thing I'm going to ask you to do, I want you to think about where you're up to on the learning today. If you think that you are here, I'd like you to put your card on red. If you think you are yellow, sorry, here, yellow, if you think you are here with all the work we've done today, can you change your card to green? Can you hold up your cards now? And your thumbs, please. Ladies, I can't see your cards. Let me see. So we've got one person still on red, fair few on yellow, lots on green. Superb, well done, that's brilliant.